Amazing.
Okay, so you mentioned foils and aerodynamics, but for those who don't know, can you explain the general concept of what a foil is?
Yeah, of course. So foil is a shape. It's the same. It's actually the shape. We're talking about a shape,
Okay.
and it's the same shape as the aircraft wing. So it starts very curved, and it converges into a point at the end. I actually should draw it. I don't have a paper right now.
I have a notebook.
Oh, you do. Cool. Not the most beautiful foil, but
You've done that before.
Yeah.
this is a foil.
Okay.
I also showed to you guys.
Very professional.
Very professional. Yeah. So this is actually airfoil, and what you want to have with this is that the air goes around, and here the two streams converge again, so you don't have a gap in air.
Okay, wait, can you do that
At
again
the
for us? Sorry.
Yeah, of course. So
Okay.
you have here.
So this is
Goes
the
on top.
leading edge.
Yeah,
That's where the
that's
air
leading
hits
edge,
initially.
where the air
Okay.
gets in, and it goes around on
Yeah.
two sides. You
Okay.
have a high pressure side on the bottom
Okay.
and a low pressure side on top.
Yeah.
And it goes around, and here those two air streams converge,
Okay.
and you achieve the best aerodynamics if those streams don't leave a hole or do not separate from each other at the end.
Okay.
They're like laminar the whole way along.
Yes,
Okay.
preferably.
And then, and the benefit from this is you get some force applied as a result. You're like using the airflow to, like that's how planes generally fly, right?
Yes, so those are actually two different designs. With the airplane, you want to generate lift, so that's the force up, so the plane can fly.
Yeah.
And we actually try to minimize the drag, so the resistive force.
Okay. So you're not using a force to guide the solar car. It's more just minimized drag.
It's mostly
that makes
minimizing the drag, yeah.
Okay.
How much testing did you do before you went on the road with that? Is there, would you test really early on
like an air tunnel or something?
in your in your development, or would you just take it out on a, well, I guess you couldn't take it out on a normal street. Where did you do the testing, and when did you start doing the testing?
We started testing, I think, 4 months before the race.
Okay.
And we were doing it on a circuit.
Okay.
So we've tested once on the Formula 1 circuit in Zandvoort.
Cool.
That was really cool. That's also where Max Verstappen and all those big events happen.
Wow.
And the other tests we have done at the airport, and there we just had a loop that we could drive continuously.
And how much can you then still change after the first test, let's say, knowing that it's 4 months before the race? If you test it and you're like, oh my god, it's just not working.
Yeah.
How much can you then actually change?
A lot, actually.
Yeah.
Especially the months before. We also start testing parts in different order.
Okay.
So we started driving, for example, without a solar panel.
Yeah.
The first tests were just purely mechanical driving on the battery.
Okay.
And then the more components pass the test, the more components you add. So you're actually adding something every week.
Okay.
And if it doesn't work, you have the whole week to fix it. And then the next week you test again. We test approximately once a week.
That's incredible. Loads of testing then.
Mm.
Very good.
Yeah.
Would you ever like to work on an airplane? Or
Rather a rocket.
that is a bit cool.
But I won't mind.
Why do you think the Netherlands has such a strong background in engineering?
I think it's maybe because of the university.
Yeah.
TU Delft has pretty good records, I think.
And that's where you went to as well.
Yeah, well, actually, I was not that ambitious when I was younger. I just choose that because it was close to my parents.
Okay, that's another way.
Yeah, but I never regret my choice. Actually, after a year, I realized how good it is and that there are so many opportunities that you can take on.
Yeah. So why is it good? Yeah, do you think there's just a range of opportunities, and I guess the teaching must be very good?
The teaching as well. Okay. I think also, very diverse. So you have many courses at the same time. And then you gain very broad knowledge in the first 3 years, and after that you have many opportunities to specialize.
Interesting.
But also high pressure, I would say.
Yeah, quite competitive over there? Or?
Yeah, I would say so.
Okay.
I feel like TU Delft is very well represented here in ISC. Like, I met a lot of people that went to TU Delft, and I didn't actually know before I got interested in the space sector that, TU Delft is so big.
Yeah.
Big in the space industry. I'd love to see it.
Yeah.
Okay, let's talk about maybe our connection here. what we have in common, and that is the space studies program. Can you tell us about how you initially heard about the program? You can go as far back in the past into your childhood as you like, maybe your inspiration and so on. But yeah, how did you hear about SSP? We'll talk about like the application process, and then we can get into how SSP actually was for you. But
yeah, maybe also why you wanted to join SSP and how did you get interested into space? I wonder.
Yeah, so there are many questions actually. I maybe start with SSP. That was not long ago.
Okay.
Yeah,
actually last year, one of my friends from my bachelor degree was going. And then I Googled it and I saw that it's this year in Houston. And then I was like, whoa, Houston. I always wanted to go there, and they promoted it a lot with NASA, and it sounds really cool.
Big space city.
Big space city, indeed.
Meet NASA, build rockets.
Yeah, so I had a call with her, and she was really positive.
Was that Kim, by the way?
Kim, yeah, okay, that was Kim actually. And then I was like, yeah, I just need to do it.
Wow.
And I applied, and
that's very cool. So how did you get passionate about space? How did you was it like a childhood dream that you had, similar to the cars that you built, the solar cars? Or was it kind of like a dream that developed later once you started studying and engineering and all of the intricacies?
Yeah, that was really since I was young, actually.
Okay. Really,
As a girl already, I loved playing with all technical things, building Lego rockets, watching Discovery Channel, all those kind of things. And yeah, always dreaming of becoming an astronaut, and still that dream didn't go away. So yeah, I think until I was 10 years old, I was really into space, and all space is super cool. Then after that, it vanished a bit, I think. At high school, I was not that much into it. I said I want to study aerospace engineering, but I didn't take it that seriously. And I've actually been looking through all the studies, medical, food, science, and when I ended up at aerospace engineering, I found my dream again, and I was like, I need to do it.
Okay. Let's really dig into that though, because you've done engineering in a broad range of topics. You could have done a lot else, but space is really your passion. And yeah, I want to understand why in particular. I guess you said you wanted to be an astronaut from a young age, so the passion just followed on from that, I suppose.
Yeah.
What do you admire space engineers in a particular way?
Absolutely. I think it's mainly about doing the impossible. So what has not been done before, and we're going to space, we're going to explore this and this and this. And the speed of the rockets as well. Yeah.
Why do you want to work on something which has never been done before?
I think it's just something that motivates me to make a contribution. Well, if it has already been done, I'm thinking, why should I then do it again? It's not that exciting, right?
Where's the excitement? Exactly.